Hello and welcome to the 3.2.1 video. In this video, we already started in class, but we're going to go over constant ratios in right triangles. And here is the title, here is the essential question if you have not written it down yet. So materials, all of this should be in the back table already. You're going to need the patterns and slope triangles worksheet, which is the one that's like this. It's double-sided, so make sure that when you staple, glue it, or tape it into your journal, you leave the other space open. Protractors, which you can find on the side. I probably left them in the back already for you. The classwork and the homework, you can get those as we move on through the lesson. So as I mentioned earlier, how is this class going to be different? If you're on a computer, you're probably watching this right now, which just means that you have the option to go at your own pace. With the videos, you can stop whenever you want. You can ask whenever you want. Some of the pros are, again, you can go at your own pace. I think the biggest con that everyone's worried about is that you won't be able to ask questions or get the material from me. However, I'm still in the classroom and I'm still going to walk around and help all of you. It's just that this gives you a different option and different ways to complete the same work that we'll be doing otherwise. So let's review and preview some of the things that we talked about. We talked about congruent triangles. And remember, one of the expectations as you're watching this video is that you continue to take Cornell notes. So congruent means equal. Equal sides and equal angles, like these examples right here. This is corresponding to this to this, and this one to the one over here, etc., etc., etc. However, similar, we still have equal angles, except this time we have proportional sides. And what this means is we've talked about this a lot already, but in other words, they have a scale factor. That's a scale factor, in case you can't tell. But they have a scale factor that makes them proportional. So whether it is to here to here, to here to here, and to here to here, you can multiply something to get to that same number. And again, with similarity, there are also things like scale factors that I just talked about, slope ratios that we'll be working on this week, and dilation. Dilation is one that we get to, and just to kind of show you again, the dilation would be when you go like that. Pretend like that's perfect, and that's the point of dilation. So slope triangles and slope ratios. This is the first lesson. Don't cheat and don't look at the bottom. Everything's at the bottom already. But a slope triangle is a right triangle. So I'll go ahead and write this down for you. Make sure you're writing this down too. Is a right triangle drawn on a graph of a line so that the hypotenuse, let's see if I spell this right. Hypotenuse of the triangle is part of the line. Now look at this example over here. There's that. Hypotenuse is the longest one right there. This is a 90-degree angle. So the hypotenuse in this case is this side right here. And like we said, this is a line. The hypotenuse is on that line. And to continue, the vertical leg, so the one that goes up and down, is a change in the y value. In this case, the change in y equals 1. And the horizontal leg, just like the horizon, the one that goes side to side, is the change in the x value. So in this case, change in x equals 5. Now we're getting a notation. What this triangle means right here, it literally means change in x. So when I'm talking about change in x or delta y, delta x, this is what I'm talking about, the triangle x, triangle y. And why do we say that? Well, right here it goes up 1. So in the y direction, because this is the y-axis, it goes up 1. In the x direction, it's over 5. And we use the lengths of the triangles to calculate the slope ratio. Perfect. So again, like I said, in this case, change in y equals 1. Change in x equals 5. So in other words, my slope ratio is 1 over 5. You can probably already make the connection. This is the exact same thing as the slope. To get from this point to this point, I go up 1 over 5 or over 5 up 1, however you want to think about it. So this was a simple one. Let's move on to some more difficult examples. Problem 368. Draw and label 3 new slope triangles with as much information as you can, including the lengths and angles. Are they similar? Why or why not? So let's start off with drawing this first part right here. So there's 3 things. 1, 2, write the slope ratios in terms of that, and 3. I'm going to do each one in a different color. So for this next one, I'm going to pick this one right here. I'm going to draw this. Draw this. If I go over, this is 1, 2, 3, 4, 5, 6, 7, 8, 9. Am I right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Ooh, good thing I recounted that. And if I go up, it's 1, 2. For this next one, I'm going to pick this point. So I'm going to go all the way over here and up there. So I know this is 10, 11, 12, 13, 14, 15. And 1, 2, 3 up. Are they similar? Well, how do I know? They have the same angle. Scale factor between this one and this one is times 2. This one and this one is times 3. So they are similar. So times 2 and times 3. Because they have a scale factor and they have the angles. And I didn't draw this in one, but this in here, but these are all right angles too. So I can use the angle theorem. What was the next part? Label the lengths, label the angles, and write the slope ratios. So for the first one, the slope ratio would be, remember again, it's always delta y over delta x. You can think of it as rise over run. Rise over run. For this first one, it's 1 over 5. For the red one, it is 2 over 10, which I can simplify to 1 over 5. And for the third one, it's 3 over 15, which I can also simplify to 1 over 5. Now notice how all these triangles, it's 1 over 5. Let me pick a different color. 1 over 5, 1 over 5, and 1 over 5. So because all these triangles are similar, and because they all have the hypotenuse on the same line, I know that the slope ratios are going to all be the exact same. So slope ratio was always 1 over 5 in this case. Now at this point, if you feel like you get the information pretty well, you can go ahead and move on and only refer to the video whenever you get stuck on problems. But I'm going to go ahead and go through and explain every single problem. Now for this one, I think a lot of you might have a little bit, some more difficulties with this. So the first task that I need to do is draw the line y equals 2 over 5x. And then draw 3 slope triangles just like we did before. What is the slope ratio? And what do you think is the slope angle? Now we're going to refer to the slope angle in a little bit. But first, what I'm going to do is draw the line. I'm going to move it a little bit just so that I have space. But if this is the point and if this is my slope, then rise over run is the same thing as 2 over 5. So I'm going to go up 2 over 5. 1, 2, 3, 4, 5. Up 2. 1, 2, 3, 4, 5. I'm going to do one more just for fun. 2, 1, 2, 3, 4, 5. And now, because I'm trying to be a perfectionist, let me get a line. Let's see if I can get this on here. Actually, let me just erase it. Can't really draw that. That's good enough. So this is y equals 2 over 5x. Now, the second part was to draw 3 slope triangles, and I'm going to pick 3 different colors again. First one, I'm going to do this one. I already have the points there, so I can use them as a guide. Don't know what that angle is, but I know that this is that, and I know that 1, 2, 3, 4, 5, and 2. Next one. 5. Oop, that's not 5, that's 10. And 1, 2, 3, 4. And the next one. Now, if you don't believe me, go ahead and count these. But if you know how I'm getting this, good for you. This and 1, 2, 3, 4, 5, 6. Are they similar? Yes, because they're all on this. They all share the same thing. They all have 2 angles. Now, what is the slope ratio? So for the green one, it'll be 2/5. Pretty simple. For the red one, I have 4/10. But I can simplify that if I divide it by 2. And I get 2/5. And for this last one, 6/15. Happens if I divide it by 3. I get 2/5. So it looks like my slope ratio is always going to be, oops, wrong color. It's always going to be 2/5. So what is my slope ratio in this case? 2/5. Now the last part, I was asking about the slope angle, and the slope angle is talking about this angle right here. Now, I don't know what it is, but I do know that the last one, let me go ahead and shrink this a little bit. Oops. This one we had 2/5. We just did one where we had 1/5. In this example, what was my angle? If you look back through your notes, it was 11 degrees. Now, notice how there's a 5 here and there's a 5 here. There's a 1 here and there is a 2 there. So knowing that, what do you think this angle is right here? And I'm not going to tell you yet. You're going to learn about this tomorrow. But let's see if you can try to think about it right now. And for this last one, to draw the 18 degrees with the slope triangle, again, similar to what we just did, you're going to have to use the protractor. So if this is our starting point, let me pick a different color just so that it stands out. 18 degrees, this is 10, this is 15, 16, 17, 18. Let me just connect those dots. So that's going to be my triangle. Just helping you out. You can continue this by yourself. And this one, again, very similar to the other one. I'll just help you set it up. X plus 4. This is a little bit difficult because I know that my y-intercept is 4. Up 1/1, up 1/1, up 1/1. Something like that. So go ahead and try to continue the classwork. Again, your goal is only to use the videos when you need to. When you are done, please let me know so that I can give you the homework.